Okay, so here we are again. We are now on lesson 8-5, and this is, oops, there's an N, another S. Yeah, that looks really good. Lesson 8-5, division properties of exponents. You would think that I would have this down by now, but I of course don't. Division properties of exponents. Okay, please don't look at the way I spelled the word lesson. Okay, so let's start with dividing powers with the same base. So we have, excuse me, multiplied powers with the same base, but now we are going to divide powers with the same base. I don't know, has my handwriting gotten messier as time has gone on? I don't really know. With the same base. Okay, so let's look at just exactly what we're talking about here. Let's say we've got 3 to the power of 7 over 3 cubed. So what's going to happen now is that this is going to equal 3 to the 7 minus 3. Okay? Remember when we multiplied, we added those exponents. Now we're dividing, so we are going to subtract those exponents. So this is going to equal 3 to the 4th power. Okay, and this works, you know, if we have, let's say we've got a to the 6th power being divided by a to, I don't know what that pen is, pencil is, a to the, let's say the 14th power. This is going to equal a to the 6 minus 14. Okay, and notice that what is going to happen is that we will have a negative exponent, a to the negative 8, and that will equal 1 over a to the 8th power. Okay, now if we have negative exponents, you're going to want to move everything first. So let's say we've got, okay, let's do it 2 ways. Okay, so first, let's just say we've got c to the negative 1 over c to the 5th. Okay, now you actually can say c to the negative 1 minus 5 being equal to c to the negative 6, which is equal to 1 over c to the 6th. Or we could move it. And in that case, we're doing it completely different. Let's say we go ahead and move that. So we've got c to the negative 1 over c to the 5th. If we just move that, that makes it 1 over c to the 1st power, c to the 5th power. Now we're going back to our previous lesson where we have 1 over c to the 1 plus 5 equaling 1 over c to the 6th. Okay, 2 ways to do it. So please understand, I want you to know what you're doing. There's no one way to do it. So look at it, see what speaks to you. I prefer doing it this way, not moving it until I know I have to, but either way will work, as you can see. Okay, so let's just look at a complex problem with this and see how we do with that, and then we will move on. Let's say we've got, let's straighten that up, x squared y to the negative 1, z to the 4th, and this is all over xy to the 4th, and z to the negative 3. And we're going to go ahead and do this kind of the way that I'm doing it. So we'll do it in the division form. So we'll be subtracting. So I'm going to start with x to the 2 minus 1. Even though this x does not have an exponent, remember, it has an exponent of 1. So we'll start with x to the 2 minus 1, and then y minus 1 minus 4 and z 4 minus a negative 3. Okay, so as long as we remember all of our integer rules, we will be absolutely fine. So x to the 2 minus 1, 2 minus 1 is 1, y, negative 1 minus 4, negative 5, and z, well, as long as we remember that we add the opposite, then we're going to know that this is 4 plus 3, so z to the 7th. And now we're going to put everybody where they belong, because they don't all belong where they are. So we've got x and z up top, x to the 1st, z to the 7th. Notice now that I'm writing my answer, I do not have that exponent up there of 1. And this is going to be over our y to the 5th. So although it looks very complicated, when you break it down, it really is quite simple. Okay, so let's go ahead and move on, and we're going to now raise a quotient to a power. Okay, raise a quotient to a power. Okay, so when we are doing this, what we are looking at now is taking our quotient, 3 divided by x squared, and raising that to the power of 2. So pretty much the way we did when we were raising oh Lord, words are like escaping me. It's late in the afternoon, sorry. When we were raising a product to a power, we made sure that when the exponent was distributed basically to both parts of the product. Here, we're going to make sure that it's distributed to both parts of the division equation here. So this will actually equal 3 squared, okay, and x squared times 2. And the reason this is 3 squared, this 3 has a exponent of 1, and that's 2 times 1, and then 2 times 2. So this will equal 9 over x to the 4th. Okay, so basically just like with the products, we are distributing that exponent to both parts of that quotient. So so let's look at another example there. Keeping it simple at first, we've got x over y squared, and we are raising this, we are cubing this. So this is going to be x to the 3 times 1, which is the power of 3, over y, and it's 2 times 3, which is 6. So x cubed over y to the 6th. Okay, so now let's go ahead and simplify some expressions, exponential expressions, with some of the information that we now have. So let's look at, let's go simple. We'll start with 3/4 raised to the power of negative 3. Okay, well, this is new. So 3 to the negative 3 over 4 to the negative 3. Look at how I distributed that. And what I'm going to do here is I am going to flip them, because neither one is where they belong. So we get 4 cubed over 3 cubed. Okay, so 4 cubed, 4 times 4 is 16, times 4, 40, 64. And 3 cubed, 3 times 3 is 9, times 3 is 27. We look for ways to simplify this. And quite honestly, let me see, 2, no, 3, no, 4, no, 5, no, 6, 7 doesn't go in, 8 doesn't go in, 9, no, 10, yeah, it looks like we're in simplest form, so we're just going to leave that. Okay, let's look at another one. Just move this ahead a little bit. Oh, for a second, did everybody get to see my or really big mistakes. Just move that out of the way. Okay, so far I haven't made any really big mistakes. Okay, let's do -1/2. And we're going to raise this to the -5 power. Okay, so this is going to equal -1 to the -5 over 2 to the -5. Okay, we're going to do the same thing as we did up here. We're going to go ahead and flip those. So this is going to equal 2 to the 5th over -1 to the 5th. Okay, so 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 32 over, and -1 to the 5th, because we're raising it to an odd power, that means we are multiplying -1 times itself, and we are doing that 5 times. So if it was an even even power, it would be it would not be a negative, it would be a positive, but since it's being raised to the 5th power, it is a -1, so this equals -32. Okay, can everybody see that? Okay, I hope that explanation was good. Let's do just one more example, and then I will free you from my wonderful, exciting voice that you're not totally sick of hearing already. 7a over m, and we are going to raise this to the -2 up. So we're doing a whole lot of negative stuff now. Okay, so remember, everything inside that parentheses gets this. The 7 gets it, the a gets it, the m gets it. So 7 to the -2, a to the -2 over m to the -2. Flip everybody on their heads and put them where they belong. M squared over 7 squared a squared, which equals m squared over 49a squared. Okay, so hopefully that all makes sense, and that's it for now.